So you are working on, based on your problem, you suggested the first homework, so the 5 process according to the NCTM standard. I'm going to briefly summarize connection and representation and moving toward the next step based on your problem. Take a look at, once again, the connection. You need to clarify several things in order to understand the concept more precisely. Connection should be made in the mathematics classroom to help students recognize and use connection among mathematical ideas. But here's, as I said, both of them should be included in connecting idea in algebra and geometry. New and old ideas connection. In the second stage, understand how mathematical ideas interconnect and build on one another to produce a coherent whole. The coherent whole should be the meaning. The meaning of that should be the same mathematical structure is in a different setting, right? I emphasize. So therefore, as you can see in the category of connection, you can see different kind of structure. And finally, recognize and apply mathematics in context of outside of mathematics. You should also understand application of mathematics, right? Other subject area and discipline, such as science, the social science, medicine, and commerce. This is the basically connection category you should understand. Also, we have investigated representation as well. Use of representation should enable students to create and use representation to organize, record, and communicate mathematical ideas. But here, as I said, in terms of using representation, there's several things you should understand. First, both process and product should be understood in terms of developing representation. Also, naive and conventional representation, both of them should be considered, not only just conventional one, but also the student-invented representation should be included. Second one, select, apply, and translate among mathematical representation to solve a problem. So translation is the most keyword in this statement. So multiple representation should be developed, right, before developing any translation between two representations. Also, strength and weakness should be considered in this category or in this statement. The third one, use representation to model and interpret physical, social, and mathematical phenomena. Modeling is not just understanding, right? So modeling means basically application of representation to the situation, like mathematical phenomena. So model, as I emphasized last time, mathematical representation and relationship. Use of a variable to represent unknown is one of the good examples. So devising representation such as equation, table, and graph that capture mathematical relationship should be the focus in these statements. I hope you understand better compared to before, right? At least in the category of connection as well as representation. One thing in terms of hierarchy, let's take a look at group A discussion. Because in your homework you also discussed group hierarchy of each statement. I'm going to give you 1 minute to read all the statement group A developed in terms of hierarchy. So everybody read the discussion developed by group A. Then I'm going to ask the other group regarding this statement, who worked on representation, group 4 and 9. What do you think? Group 4? Where is group 4? Yeah, you just read the group 8 discussion, right? About hierarchy of the statements in the category of representation. What do you think about? I'm just basically asking because three groups have probably different point of view about the hierarchy of the representation. So I just want to discuss together and then guide some direction to you. That's basically the purpose of discussion. Okay. So why don't you tell us your opinion about group A perspective on hierarchy of the statements in the category of representation.
저희 같은 경우는 1번, 2번, 3번 디스커션을 했었는데
Yeah.
그러니까 커넥션하고 좀 다르게 리프레젠테이션을 조금 이제 관계를 조금 만들기가 좀 어려워서 이 부분에 대해서 조원끼리 얘기를 많이 했었는데 아무래도 3번 같은 경우는 일단 현상들을 모델링하고 해석하기 위해서는 표현이 있어야 된다는 생각을 했고
Yeah.
2번에서도 2번을 하면은 수학 문제들을 풀기 위해서 수학적 표현을 고르고 적용을 해석하라가 뜻이 되는데
Yes.
이 수학적 표현들이 존재하기 위해서는 먼저 어떤 현상을 해석하고 수학적 표현을 만들어야 된다고 생각을 해서 사조 같은 경우는 일단 1번, 2번, 3번 순으로 수식적 그런 관계로 저희 이해했습니다.
So what about group A opinion about what just said? Where is group 8? Group A member? Group 8. Yeah. Why don't you tell us your opinion about that? He just pointed out very important thing, right? So basically, before discussing second and third category, students should develop basic representation. Otherwise, it does not make sense, right? For instance, translation, right? Modeling is not possible without developing just a basic representation. Yes. 이거 마이크 대고 이야기해 주세요. Group A? Anyone would be fine. Because you discuss in this way, so I'm just wondering, what is your reaction about that?
네, 저희도 2번과 3번을 하기 위해서는 1번이 필요하다고 생각을 했는데 거꾸로 2번을 잘할 수 있는 것이 1번을 아예 못하는 게 아니라 1번을 조금 하는 상태에서 2번까지 할 수 있다면 1번의 더 어려운 수준의 문제도 더 잘 해결하는 데 도움이 된다고 생각을 해서 저희는 1번과 2번은 상호 보완적이라고 생각을 했습니다.
What about this statement? Can you explain to us?
3번의 경우는 물론 1번, 2번을 할 수 있어야 하는 것이라고 저희도 생각을 했고 다만 정보도망교 문제 중에서는 그냥 답은 그냥 쉽게 찾을 수 있는 문제들이 거의 대부분이어서 그렇게 얘기를 한 것이고 정말 제대로 이해하고 문제를 제대로 해결하려면은 1번, 2번이 필요하다고 저는 생각했습니다.
What about the group 9? Where is group 9? Yeah. Why don't you tell us? You just heard the different group perspective on that. So what do you think about the two different point of view?
저도 8조가 제안한 것처럼 1과 2가 수직적이라기보다는 상호 보완적이라는 말을 어느 정도 동의하는데요. 그 뒤에 말 중에 1을 어려워하는 학생이라도 제시된 식만 다룰 줄 알면 3에 해당하는 문제를 어렵지 않게 해결할 수 있다고 했는데 저희 쪽 생각으로는 3의 카테고리에 해당되는 게 수학적인 상황으로 물리적이거나 사회적이거나 수학적인 상황을 수학적 식으로 모델링을 하는 과정도 이 3에 포함되어 있다고 생각을 해요. 그래서 문제를 단순히 그냥 수식이나 비율 들어있는 거를 해석하는 능력뿐이 아니라 그 수식을 때문에 1을 어려워하는 학생이라도 제시된 식만 잘 다루지 않다고 해서 3번에 있는 모델링을 잘할 수 있을 거라고 생각을 동의하기가 좀 힘든 것 같습니다.
What about group A reaction to that?
1에 해당하는 문제도 수준의 차이가 문제에 따라서 많이 날 텐데 1에 해당하는 문제 중에서 쉬운 거를 해결할 수 있지만 어려운 문제는 정말 어려운 게 있을 수 있기 때문에 그거를 해결하지 못한 학생이라도 그러니까 저희가 저희 맨 마지막에 우측 문장을 갈 경우는 그것보다는 사실 그 다음 문장에 저희는 좀 더 힘을 쓰는 건데 저 문장은 이제 우리나라 중학교, 고등학교 문제들을 생각을 해서 얘기를 한 거거든요. 그래서 그러니까 나와 있는 문제들이 대부분 그거를 제대로 이해하지 않더라도 식을 잘 다루면 답을 낼 수 있다는 그런 얘기를 하고 싶었습니다.
I think group A develop even though you may disagree with some of the statement, but I think group A develop some important perspective you should consider while you're working on any mathematics education statements. When you develop any hierarchy, for instance, according to my understanding of NCTM standard, this one is correct, 1, 2, 3, in terms of hierarchy, okay? Because that is the intention of NCTM standard. Any statement, if you read carefully NCTM standard, the order of the statement intentionally expressed in that way. That makes sense? For instance, in representation, compared to 1 and 2, 2 is much more higher in terms of understanding representation. Third one, I think the most higher level compared to 1 and 2. That is the intention. However, one thing you need to remember, Group A point out important thing. In other words, mutual interaction between 1 and 2, between 1 and 3, between 2 and 3. Do you agree with that? Right? Understanding and comprehension, representation, comprehension of any connection is not going to be isolated, right? Mutual understanding, mutual development is working on, right? Continuously, because understanding is continuous variable, not discrete variable, right? Just based on your experience, understanding is not just discrete mathematics, right? Continuous variable. You are always working on your understanding, right? You are thinking continuously, right? That's going to be dilemma. Think about it. There is continuous variable, but how can you interpret it by using this continuous variable? Understanding, how can you understand continuous variable by using discontinuous variable or discrete variable? It's not possible, right? Because continuous variable means it's continuous, up and down, from time to time, moving back and forwards, right? Just think about your experiences. That's why NCTM standard, just intentionally 1, 2, 3, they expressed. However, right, they never discussed in the NCTM standard about hierarchy. Make sense to you? Because of those kind of dilemma. So mutual understanding, mutual interconnection between 2 or 3 statements. So Group A pointed out important thing, right? So mutual understanding, mutual development, continuously, right? Working on. However, in terms of hierarchy, as I said, 1, 2, 3 should be the correct one, right? Make sense to you? Any other comment or question? Any question? Then I'm going to finish connection and representation. Do you have any other question regarding connection and representation? As I said, as you can see, right, connection representation, I think 7 groups worked on connection and representation. The other three groups worked on problem solving, reasoning, and proof. I'm going to review problem solving as well as reasoning and proof. Before going further, any other question? Today, I'm going to start with a funny picture. What do you think? For a fair selection, everybody has to take the same exam. Please climb that tree. Why monkey is so lucky? Even though this cartoon implies, some funny thing, but I think by using this cartoon, it implies many things in our education system. Think about, I worked on in my dissertation a communication approach to cognition. Basically, communication approach to cognition, according to that theory in learning and teaching mathematics, one of the most important things, individual differences in terms of learning mathematics. In other words, there are 50 students in our class. There are 50 different approaches to the same mathematics. That's going to be a dilemma in learning and teaching mathematics. In other words, if I'm going to select any two of you, their cognition is same or different. If I'm going to select randomly, for instance, in this class, out of 50 students, what do you think? In terms of epistemological perspective, do you understand what is epistemology, right? How to know knowledge, or how to know mathematics, right? In terms of epistemological perspective, if I'm going to select any two of you among 50 students, are their epistemology the same or different? Today is the 7th, right? 노시윤? What do you think? Because I'm asking this question, if you're going to go to the classroom, for instance, middle school, high school, there are 30 students. If there are 30 students, if you're going to select any 12 students, their epistemology, in other words, the ways of knowing mathematics, they're different, but they can be the same. What do you think? Just your opinion. 무슨 말인지 알아들었어요? 제 질문이? But think about your answer. What did you assume? Because nowadays in the area of mathematics education, there are two perspectives on mathematics. One is absolutivism. That is mathematics always true. The other is relativism. In other words, mathematics has been developed depending on culture and other social issues. Therefore, it's not that simple. In other words, even though there is mathematics, but the mathematics is already true, this is the philosophical issue. Anyway, so I'm not arguing right now, it's too complicated, because, if I'm going to teach just, mathematical philosophy or any, epistemology, it's going to be taken maybe one or more than one semester. That's why it's not that simple. But if I'm going to summarize just in one word, from my perspective, if you're going to select any 12 students in the classroom, any classroom, their epistemology cannot be the same. In other words, 2 students, in terms of developing their mathematical knowledge, they are different. So that's going to be a big dilemma in terms of learning and teaching mathematics. So you need to think about this issue as a pre-service teacher always. Without understanding this perspective in depth, you are going to meet many dilemmas in your teaching. That's why I'm addressing this issue first. Okay? But anyway, so you understand the characteristic of each student. Otherwise, as a result, you are going to teaching in this way. Based on this cartoon, you want to do the same exam, but all of a sudden, like this cartoon, you are going to develop this kind of teaching in your teachings. But it's not that easy, right? Based on this kind of characteristic, right? Or considering this kind of characteristic among students, you need to develop the teaching method. That's why teaching is not that easy in terms of understanding educational system like this. I hope it's fun to you, this cartoon. There is a fish as well. Did you notice? Anyway. So as I said, I'm going to move to problem solving because, as you can see, 2 groups, group 6 and group 10, worked on problem solving. And then finally, I'm going to review reasoning and proof, worked by group 3. Oops, nice connection. Oh, I just reviewed. Oh, it's okay. I just want to explain the contents. That's why I already finished. I moved to the problem solving. I just reviewed the connection and representation. You can review by using this, PowerPoint once again. Principle and NCTN standards, problem solving should enable all students. There are 4 statements: build new mathematical knowledge through problem solving, solve problems that arise in mathematics and in other contexts, and apply and adapt a variety of appropriate strategy to solve a problem. Monitor and reflect on the process of mathematical problem solving. But if you're going to, because most of you worked on the statement already, I'm going to briefly summarize key perspective you should understand. If you carefully read each component, as you can see, build new mathematical knowledge through problem solving. As I emphasized last time, build means the extension, right? Extension of knowledge. I also emphasized last time problem versus exercise. You understand what is the differences between 2 of them, right? Problem, exercise, just a routine problem without building or new knowledge. However, problem, right, can be used to develop student new knowledge. That's going to be big differences. A second one, solve problem that arise in mathematics and in other contexts. If you are going to carefully read NCTM standard, this word is this keyword, arise. Because worthwhile in their world and experience, who is there, do you think? Who is there? I emphasize worthwhile in their words and experiences. Worthwhile in terms of whom? Solve a problem that arises in mathematics and in other contexts, but this arises, who is the subjective should be? Who is the subject? Right. Students, right? So in other words, problems should be worthwhile in students' words and experiences. But one thing you need to remember, arise is neither apply nor model. What is the meaning of that? 17. 조연이. Do you think what is the meaning of that? In connection, did you see this in connection representation, did you already see this word, right? I'm going to show you, for instance. In connection, you can apply, right? Apply mathematics, this is a higher level compared to the other connection statement. Also, in representation, did you see model, right? Apply model means very higher level of mathematical thinking ability. However, here, in problem solving, they use the word. Arise. That's why I'm talking about arise is neither apply on nor model. From your perspective, what is the meaning of that? Why I'm emphasizing? Just think about the statement, solve problem that arise in mathematics and in other contexts. Also worthwhile, it should be worthwhile in their work and experiences. What is the meaning of that? I'm going to give you a couple of minutes. What about the Kim Dong-hyun? Yes. What about your opinion? Anyone? Why I'm using this statement, arise is neither apply nor model. Just think about problem. What kind of problem there might different. If a student can apply problems, or solve problem apply to other context or model the problem. In terms of problem, what is the differences? Apply the problem, model the problem compared to analyze the problem. Do you think what is the main differences from your perspective? There are three different kind of problem. right? Model the problem, apply the problem. What about the arise the problem? Do you think what is the main differences? That's basically my question. Yes.
좀 우연성이 좀 포함되는 느낌.
우연성? 어떤 측면에서 우연성? 좀 더 설명해 주시고.
어라이즈는 그러니까 모델이나 어플라이즈는 이렇게 유도하게끔 되는 거라면
네.
어라이즈는 약간 자연스럽게 맞닥뜨리는 느낌이 있고.
Yeah. That's the key word. 자연스럽게. That mean modeled, applied mean much more rigorous in terms of mathematical problem, right? Mathematician or math educator can develop modeling process, application process, like in terms of developing any problem. However, realized problem much more naturalistic. In other words, student may be much more comfortable with solving realized problem, right? Because here, worthwhile in their world and experiences. For instance, let me give you an example. Even though, because think about this one. How can you make a problem arise from other contexts, not only in mathematics, but also in other contexts, right? But arise the problem is not that easy because it's not your perspective, it's not teacher's perspective, it's not researcher perspective, it's not mathematician perspective, right? It should be worthwhile. That's why who is there? Students. So if you're going to teach any mathematics based on your experience, even though you modeled, you used to model the problem, apply the problem in the classroom, but student all of a sudden what? It's not funny at all. It's not worthwhile in our experience or in our world. Teacher, what are you talking about? This is not a good problem, right? This is not related to our life or our world, our experience, right? You are going to experience that kind of thing in the near future if you are going to be a teacher. So that means, realize means worthwhile in students' world and experience. That is the meaning of realize. In other words, students can see the problem is worthwhile in terms of their experience and in terms of their world. For instance, I think last year in this class, some of students developed idol problem because most of students are interested in idol. Do you know what is idol, right? It's not English, it's Korean. Idol. Those kind of problem students may have interest in because in their world that's worthwhile to watch what is going on, right? That kind of context may be worthwhile. So therefore, arise is neither apply nor model. Maybe from time to time it can be applied, it can be modeled. However, not always, right? Arise much more naturalistic, as he pointed out, right? 자연스럽게, 그죠? But this is not from mathematician point of view. This is not from math educator point of view. This is from student point of view. That's why I differentiate. Arise is neither applied nor model. Do you understand why I write down this statement? For your better understanding? That's why you understand arise. Build new mathematical knowledge through problem solving. I hope you understand better. Solve problems that arise in mathematics and in other contexts. I hope you understand better. That's why I'm emphasizing this statement. Arise is not simply apply, no model. The third one, apply and adapt a variety of approach strategy to solve problem, categorize and compare different strategies. Similarly, like representation, if you are going to adapt a variety of appropriate strategy to solve problem, you should develop, right, at least two different strategies, right? Make sense? Otherwise, how can you adapt? There are two things, right? Out of two things, you should adapt one of them, right? That means you already developed what? Two different strategies. Otherwise, you cannot use the word adapt. Make sense? Like a multiple representation. Without multiple representation, how can you select one of them? Like similarly, adapt means you already developed multiple strategies to solve problem, and then you need to select one of them. Therefore, I'm emphasizing different strategy, categorize and compare different strategies and select one of them. Well, this is the better way compared to others. And finally, monitor and reflect on the process of mathematical problem solving. Monitor and adjust their strategy. I emphasize at the beginning of the explaining the category of problem solving, metacognition, right? In other words, cognition of cognition, this category. Now, do you understand better regarding the four statements in the category of problem solving? I hope. And based on this understanding, let's work on problem solving. Hope you understand better now. Let's take a look at problem group 6. Why don't you start ping pong? Let's see. 35, 5, 7. Let's see, 2. Let me check. 3번부터 들어볼까요? 먼저 태정이가 지나고. 태정이 발표했었어요, 지난번에?
저번에 했었어요.
네? 지난번에 했었어요? 예. 했습니다. 아, 발표했네요. 성룡이는 했어요, 발표?
네.
네, 발표했고. 다 발표한 사람들만 나와. 3번이 1순위도 발표했죠. 발표했어요? 1순위. 괜찮아. 그냥 공평하게 기회를 주려고 그러는 거예요. 아, 여기 있겠네 이제 이승주, 고영경, 김승민. 자, 발표 안 한 사람. 승주 학생 발표. 이승주. 네, 한번 왜 3번을 선택했는지 자기 의견을 좀 말씀해 주십시오. 제가 아까 3번은 말했죠. 스트레티지가 멀티플 스트레티지가 있어야 된다. 그죠? 왜냐하면 멀티플 스트레티지 중에 한 가지 스트레티지를 어댑트, 선택할 수 있는 능력이라고 했는데 Why did you select number 3? Just in your first impression, why did you select number 3? Yeah. Why did you do that?
그게 좀 더 해보는 나가는 과정이 공부력과 비슷하다고 느꼈는데 그거 공부법하고 어떻게 다른 방법이 있을 거라고 생각해요.
Dividing fine segment is going to be one strategy. Did you think in that way? Can you explain a little bit more? Even though you selected the answer, but there is no justification. Let's hear other student then. What about we then? 고영경? Yeah. Why don't you tell us your opinion about that? 예,
문제를 언제 푸느냐가 좀 중요할 것 같아요.
예, 계속 이야기해 보세요.
그
언제 푸냐가 왜 중요한 이슈가 되죠?
이번에 새로운 그 수학적 그 지식을 알아가는 거잖아요. 그러니까
예,
이거를
예.
뭐 무궁무적으로 배우는 단계에서 제일 처음에 제시를 해줬다면 이번이라고 대답할 수 있을 것 같아요.
예, 예.
그게 아니라면 저는 그게 모르자는 상관?
그러면 여기서 스트래티지를 뭐라고 보시는 거예요? What kind of strategy did you see here? Here is apply and adapt a variety of approach strategy to solve the problem. So at least in order to this problem can be included in here if there are at least two more strategy and the student can adapt, right? Because adapt a variety of approach strategy to solve the problem mean still need to see some different kind of strategy at least from the problem solving, and they need to adapt to one of them, right? That is the meaning, I think, direct meaning of the statement, the third.
그 문제 1번, 2번에 두 문제로 구성되어 있잖아요.
네.
1번에서 직접 계산을 좀 해야 되는 것 같고 2번 해결하려면 극한 개념을 좀 이용을 해야 되니까.
That's the two different strategy, right?
네.
So what do you think? Group 6. It seems to her at least, right? This is one strategy, this is two strategy, and that's why she selected number 3. Any reaction from group 6? Yeah, why don't you?
우선 저 문제가 처음에 구조법을 도입할 때 시작으로 시작되는 문제거든요. 그러니까 구조법의 개념을 소개하기 전에 도입으로 시작되는 문제라서 잘 지적하셨듯이 도입 언제 푸느냐에 따라서 이제 달라질 수 있겠지만 그래서 1번이라고 보는 거고요. 3번에서 이제 말하는 그 appropriate strategy가 이제 다양하다는 게 뭐가 다양하다는 건지 사실은 잘 모르겠습니다. 1번 문제랑 2번 문제, 1번 문제가 여러 가지 그 적절한 그 스트래티지를 이용해서 풀 수 있고 2번이 뭐 여러 가지 적절한 스트래티지를 풀 수 있다고 보이는데 사실 잘 거기서는 잘 모르겠어요.
Maybe she wanna point it out. This one is kind of a discrete process, in terms of developing n minus n. But the second part, she wanna point out kind of the concept of limit should be considered. Because this is discrete process. This is kind of much more closer to continuous process. That's why she may think. I'm not sure. Maybe you had better ask her. But my interpretation of what she just said, this is kind of discrete process because n equal to half and quarter and blah 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 and continuous. But this one much more close to continuous variables. That's why maybe in terms of the finding of n minus n, right? Oh, do you have any reaction to that? Yeah. Any other opinion about what just said? Group 6. Any other comment from group 6? No comments? Express yourself if you want.
저는
마이크를 대고 이야기해주세요.
저는 여기서 다양한 전략이 없다고 생각하거든요.
네.
왜냐면 그냥 잘게 잘랐고 그 차이 정도만 계산하는 거지 뭐 넓이를 구하는데 전략이 바뀌고 막 이런 거를 발견을 못해서 전략은 다양하지 않다고 생각합니다.
One of the thinking, the definition of strategy should be clarified, right? For instance, I don't think the same thinking process, but one is discrete, the other is continuous. This is not going to be different strategy. Based on your experience, what is the meaning of different strategy? Different strategy meaning approach to the same problem by using what? Different method, right? Not the same method. Make sense? Therefore, you need to clarify what is the meaning of strategy. Strategy means, right? In order to solve any problem, right, you need to develop a method, right? That means different strategy means different method, not the same method or similar idea. Make sense? Therefore, you need to understand or you need to clarify the word strategy. That's going to be reduced, right? Discussion about this issue. Anyway, let's move to the next problem then. Oh no, let's hear second option once again. This is going to be 2. 재훈이 했니? 신재훈. 재훈아 발표했니? 발표 안 했지?
아는 것 같습니다.
재훈이 발표 안 한 것 같아. You selected 2, option 2. Can you tell us a little bit more about your opinion?
일단 그 문제를 설명할 때 십자수 뭐 이런 표현을 했잖아요.
네.
그래서 그 표현 덕분에 일단은 이게 좀 자연스럽게 발생된 그런 프로블럼이라고 생각을 했고 이제 1번을 선택하지 않은 이유는 이걸 보고서 사실 저도 이제 구분구조법을 떠올리긴 했는데 저기 2번 문제까지만 해서 과연 학생들이 이 문제만으로 어떤 확장된 새로운 수학적 지식을 과연 알아낼 수 있을까라는 그런 의문이 들어서 그래서 1번을 선택 안 하고 2번을 선택했어요.
That's a really good point. So he's pointing out an important thing. From your perspective, Group 6, what is the new knowledge? Basically, he's asking that question. Can you respond to that question? Group 6, anyone? So what did you consider new knowledge while working on this problem?
저희는 이 문제에서
네.
구분구조법에 대한 그런 기본적인 개념이나 나중에 뭐 구분구조법을 배울 때 구체적인 예시가 되는 문제를 제시했는데요. 여기서 그러니까 구분구조법의 약간 그거에 대한 수학적인 추측이랄까 그런 것을 얻는 것을 수학적인 그 뉴 널리지를 얻는 거라고 생각해서 이 문제를 제시했습니다.
Tell us a little more. What kind of?
이 문제를 통해서 이렇게 세분화해서 잘라가면 이 넓이와 비슷해진다는 그런 그것을 경험함으로써 이런 앞으로도 이런 비슷한 문제를 접했을 때 그렇게 풀 수 있지 않을까는 추측을 했죠.
Okay, from my understanding, I'm not sure I fully understood what he just said. 그 커링하는 게 있죠. 커링하는 게 지금 1차원적이잖아요. 구분구조법 할 때는. 근데 이거는 지금 2dimensional stage잖아요, 그죠? 그렇기 때문에 서로 다르다고 봤다고 저는 이해를 했거든요. What do you think about that new knowledge? In other words, so cutting domain n is going to be increased to infinity, right? Cutting so as much as you can, you need to cut it out. If you are going to find out area of the graph and the x-axis and the y-axis, but this one is even though it's a two-dimensional stage, basically conceptually why cutting refinement, right, is so important from I think perspective of Group 6. That's what I understood. Yeah, Joe.
그러니까 그런 부분들까지 이제 저희는 내다볼 수가 있는데 제 말은 학생들이 딱 저 2번 문제까지만 보고 과연 그런 것들의 지식을 알아낼 수 있느냐라는 건데 만약에 그런 부분까지 좀 다뤄주려면 제 생각에는 3번, 4번까지 한 문제가 한두 개 정도는 더 있어야 된다고 생각해요.
What kind of problem can you think of?
구체적으로요?
Yeah. For instance, then we can better understand your perspective. Then. For instance, number 3. because one is half and quarter, right? 2분의 1 cm, 4분의 1 cm, and n minus n, right? And then next question, 눈금이 간격을 점점 더 작게 한다면, in other words, it's going to be decreased, 1/4, 1/8, 1/16, something like that. Anyway, so what problem can you make, for instance, if you'd like to make number 3 after that?
예를 들어서 그런 구분구조법의 방향을 구분구조법으로 이제 원하는 방향을 잡았다면 이 문제에서 학생들에게 알려주고 싶은 그런 수학적 지식을 그러면 뭐 예를 들어서 면적이라던가 길이에 대해서 좀 더 학생들이 구체적으로 다뤄볼 수 있게끔 문제를 하나 더 던져야 될 것 같아요. 예를 들어서 2번까지만 해서는 그냥 어떤 저 상황에 해당되는 그냥 정사각형의 개수 그냥 그 정도로만 이해하고 끝날 수 있을 것 같거든요. 더 그렇게 던져주지 않으면.
Then, for instance, maybe in the case of the number 1, instead of half or quarter, you can maybe add half and quarter, 1/8, 1/16, something like that. More cases, and then you can ask, that's going to be satisfied then from your perspective? For instance, if I'm going to add, instead of this case, let's say n equal to half, n equal to 1/4, n equal to 1/8, or n equal to 1/16, and dot, 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 dot. And then you may ask the same question. That's going to be enough, or?
저는 그런 몇 개 더 예시라기보다는
Yeah.
구체적으로는 생각을 안 해봤고.
Well, just in a direct question, in terms of refined segment, between refined segment and area of the apple, that kind of question, can you expect?
저는 그런 쪽으로 좀 더 생각을 했던 것 같아요. 그 정도는 던져줘야 뭐 학생들이 방향을 그쪽으로 좀 잡아서 생각을 할 수 있어요.
I think about that's a really good question because because you develop right from your group 6 perspective, the new knowledge related to area of the apple, right? Then he's pointing out, Jaewoon pointing out, in that case we need to clarify our question refinement, the question related to the relationship between refinement and area of this apple. What is your reaction? I think that's a really good question. And anyone, group 6. That question should be asked in order to develop new knowledge from this problem. Any reaction? Yeah.
제가 좀 정확하게 이해를 못해서 리파이먼트가
작게 세그먼트 작게 자르는 거. 2분의 1, 4분의 1, 8분의 1 계속 잘라가는 거예요.
예.
그거 과정과 이 에어리어와 관계를 좀 더 구체적으로 질문해야 되지 않냐. still imply는 되는데 여기서 작게 자를수록 그죠? 애플이 면적이 더 가까워진다 imply는 되지만 학생들이 재훈이 의견은 다이렉트 얻을 수 있는 것 같지는 않다. 좀 더 그래서 3번이나 4번에서 이 refinement, 즉 세그먼트를 더 잘게 자르는 과정과 이 사과의 면적에 대한 좀 더 직접적인 질문이 필요하지 않냐 이러는 거예요.
그 예시라는 게 3번에서 이 위에서 얻을 수 있는 그 예시를 가지고 명대가 일반화하여 뭐 이런 문제를
아니면 이럴 수도 있죠. 예를 들어서 눈금이 간격이 점점 더 작아지면 사과의 면적은 어떻게 되는가 뭐 이런 식으로.
사과의 면적.
네, 눈금이 작아질수록 사과의 면적은 어떤 변화가 일어나는가 뭐 이런 구체적인 질문을 던져줘야 된다. 그래야 학생들이 그 문제로부터 지금 여러분들이 원했던 그 직접적인 뉴 날리지를 얻을 수 있다는 거죠.
네, 그것도 좋은 생각인 것 같아요.
네. I think that's a really good point because in terms of developing any assessment item, as Jaeyoon pointed out, we cannot infer, as I emphasized many times, right? The problem is, I agree with Jaeyoon's opinion. Because maybe if you are going to use this problem, maybe some of the students develop what you wanted, right? Obviously. But I assume maybe others, probably some of them may not develop those kind of concepts. In other words, the relationship between requirement, process, and area of the apple. Make sense to you? Any question? Yeah, this is a really good discussion. That's exactly what I wanted from discussion. Because by using this process, I think you can deepen your idea, right, of file process, especially problem solving, right? That's exactly what I want. So that's why you need to think by yourself, how can you critique others' problem? Then after critique, right, you can, I think, develop much more rigorous way in terms of, the first statement based on this problem. I think that's a really good point. Any question or any other comment on that? Or any objection? What we just talked about? Yes.
저 문제를 통해서 굳이 사과의 넓이를 좀 더 정확하게 구하려면은 용품을 있게 해야 된다까지 그 사실을 완전히 다 새로 그 학생들이 그거를 알게 되지 못하더라도 그냥 저 사과의 넓이에 가깝게 구할 수 있는 것이 용품의 간격을 점점 작게 할수록 그 두 개의 차이가 줄어든다. 그거 자체도 하나의 새로운 지식이라고 볼 수 있고 그게 더 다른 이제 학습과 합쳐져서 더 완성에 가까운 지식을 만들 수 있기 때문에 저 자체로도 하나의 새로운 지식이라고 볼 수 있어요.
Right, I agree with you. But the group 6 has the purpose. That's why I heard from group 6, what is your purpose, new knowledge? That's why I'm asking, first, think about in my approaching your our discussion, because the intention is so important. That's why I first asked the intention of group 6. But if that is the intention of group 6, I think Jeon is incorrect in terms of developing those purpose, right, by using this problem. But as you pointed out, that kind of thing can be obviously new knowledge, right? Make sense to you? What I'm talking about? That's why always as a pre-sub teacher or just in-sub teacher, teachers always has the purpose or any intention in their teaching or in developing their assessment item. But in order to develop their intention or their purpose clearly to student, their way of approaching should be clarified, right? That's why I'm asking, I always connecting. I do have some new knowledge as well in this problem, a lot of things. But those kind of intentions should be addressed or should be transferred, right, to student. That's going to be problematic. That's why you always need to consider two different perspectives. One is what is your intention? What is your purpose in terms of developing this problem? And then what kind of things can you see in terms of relationship between your intention and student development? That's why I'm asking that way. Obviously, you can see many new knowledge from this problem depending on your perspective, right? Make sense to you? Okay. Let's solve one more problem and then I'm going to finish. This is once again problem from group 6. 곡선 fx는 2x 스퀘어 루트 x의 x는 0에서 1까지 길이를 구하여라. 어때요? 어이구야. 뭐가 이렇게 나왔죠? 다음 시간에 아무튼 디스커션 한번 해보죠 뭐.